In order to find the internal loads in the structural member at a specific point, all we need to do is to create an imaginary cut at that specific point and divide the member into two separate pieces. Now for analysis, we can pick any one of those halves and solve for the internal loads. Typically, we select a half that have least amount of unknowns. So in this case, I'm going to pick the left hand side, as the right hand side have a roller at A and a pin at point B. So let's go ahead and draw the free body diagram. Now at the specific cut, three internal loads will become exposed. We have a horizontal force of normal given as NC, a vertical force, that is our shear force, given as VC, and a couple moment given as MC. Now once we have our free body diagram, let's go ahead and apply the equilibrium conditions. Here, starting with summation of forces along the x-axis, I have just two forces, one an external load of 4 kilopounds and our normal force NC in the horizontal direction. This gives us the value of normal force as negative 4 kilopounds. Now one thing to keep in mind, the negative sign is just indicating the direction of the force. So in actual case, the normal is acting in the opposite direction in which we have drawn on our free body diagram. Similarly, we can do summation of forces in the vertical direction that give us the value of our shear force equals to negative 1 kilopounds. Finally, we have our summation of moment equation that we can write on any point on the structural member. However, we select the summation of moment at the cut so that the normal force and the shear force won't contribute into the moment equation. Here I have an external load of 4 kilopounds that is making a counterclockwise moment, having a moment arm of 3. Next, we have our distributive load that is converted into a point load, having a moment arm of 2 feet that is also producing a counterclockwise moment. And lastly, we have our couple moment MC, equating it to 0, give us its value of negative 14 kilopound feet.